Good afternoon, my dear students. Today we will discuss velocity analysis of 4-bar mechanism. So that analysis will be by using instantaneous center method. Okay. So first of all, we will find out the instantaneous center of 4-bar. Then we will find out the velocity of different link. If one link is given, velocity of one link is given, other link can be find out by using instantaneous center method. Okay, so first of all, see how to find out the instantaneous center. So of velocity analysis of 4-bar mechanism. Okay, so first of all, we will find out, we will draw the 4-bar mechanism. Okay, so suppose this is the 4-bar, so there will be 4 links, 1, 2, that's 3, that is 4. Okay, so in a 4-bar mechanism there will be 4 turning pair. So there will be 4 turning pair. So how to find out the instantaneous center? So for instantaneous center, one formula is there. Instantaneous center, that is n to n minus 1 by 2. That is the formula. So n is equal to number of link. So in a 4-bar mechanism there will be 4 link. So number of instantaneous center will be 4 into 4 minus 1 divided by 2. So 4 into 3 divided by 2, that is 6. So there in a 4-bar mechanism there will be 6 instantaneous center. Now what will be the location of this instantaneous center? So in the previous class we have discussed, in a sliding pair instantaneous center will be in the at infinities, and in case of turning pair, so in case of turning pair, if this link is with respect to this point, so instantaneous center will be, this is with the instantaneous center. Okay, so there are 4 turning pair, so there will be 4 instantaneous center at the junction. Okay, so 4 instantaneous center, suppose link number 1, link number 2, link number 3 and link number 4. So instantaneous center I12 or I21, the same. So first instantaneous center you can look at here, I12, it is I13, it is I14. So between 2 to 3 you can write here I23, 3 to 4 I24, then here for 3 to 4 I34. So 6 instantaneous center are there. Now I12, so I12 between link number 1 and 2, that is I12. 13, that is not known, that we have to find out. I14 between 1 and 4, so that is I14. 23 between 2 and 3, I23. I24, so I24 is another, you have to find out. Then I34, so that is 3 to 4, I34. So we have to find out instantaneous center I13 and I24. So how to find out this 2 instantaneous center? That instantaneous center now we will find out. So for that, first of all you draw a circle and locate 4 point 2, 3, 4. 1, 2, 3 and 4. So join each point. So 1 2 2 3, 1 2 2 3, here 1 2 2 3. So 1 2 and 2 3. So join 1, you have to find out 1 3, I 1 3. So I 1 3 will be this side, I 2 and 2 3, I 1 2 and 2 3. So that will be this side. So I 2 and 2 3, I 2, you can see here I 1 2 and I 2 3, I 1 2 and 2 3. So you from this point I 1 2 and I 2 3 draw a straight line. Okay. So in that this side I 1 4 and I 3 4, I 1 4 and I 3 4. So from that you join another straight line, extend another straight line. So that two line intersect, that is I 1 3. So I 1 3. Now another instantaneous center, that is I 2 4, we need to find out. So how to find out I 2 4? So I 2 4. So join 2 and 4. So I 1 2 and I 1 4. I 1 2 and I 1 4. Here you can see I 1 2 and I 1 4. So you can extend this line. Another is I 2 3 and I 3 4. So I 2 3 and I 3 4. So you extend this line. So that becomes the I 2 4. Okay. So we have find out 6 instantaneous centers. Okay. So we have learned how to find out the instantaneous center in case of 4-bar mechanism. That is, if you consider it is case number 1. Now another 2 cases we will discuss. Another 2 cases, consider 4-bar mechanism where 2 links are parallel, 2 vertical links are parallel. Okay. So that is link number 1, link number 2, link number 3, link number 4. So similarly you can find out 6 instantaneous center will be there. That is I 1 2, I 2 3, I 3 4, I 1 4. So another 2 instantaneous center, that is I 2 4 and I 1 3. We need to find out. Okay. Now you can see one, 2, 3 and 4. So I 1 2, we need to find out 1 3, I 1 3. So I 1 3, how you can find out? If you join, if you extend I 1 2 and I 2 3, I 1 2 and I 2 3. So if you join, so one line will be there. Another I 1 4 and I 4 3, I 1 4, I 3 4. So you also extend this line. So you can see that these 2 lines are parallel to each other. Then where it will meet? Mathematically, we can say that it will meet at I 1 3. It will meet at infinity. Okay. So in which cases instantaneous center will be at infinity? In case of sliding motion. In case of sliding motion, we have seen that a block which will be in the sliding block. So in that case, instantaneous center at infinity. Okay. Now another instantaneous center I 2 4 you have to find out. So I24 284 joined. So it will be I12 and I14. I12 and I14. You extend it. And another is I23 and I34. I23 and I34. You also extend it. So that becomes the I24. So 6 instantaneous center we have find out. In that case is two vertical links are parallel. Now another case, we need to find out. In that case, where two horizontal links are parallel to each other. So similarly, 1, 2, 3 and 4. Okay. So that is I12, this is I23, I34, I14. Okay. So 6 instantaneous center. Among them we have find out 4 instantaneous centers. Now we have to find out I24 and I13. So for I12 and I13, we can find out by extending this I12 and I23 and I14 and I34. That is I13. Now another instantaneous center I24. So how can you find out? So you can extend this line. Also you can extend this line. That means I24, it will meet at infinity. Okay. So these three are the cases we have discussed here. We have find out how to find out the instantaneous center. Okay. Now for finding out the velocity of different link in a mechanism, we have two types of velocity. Okay. So there are two types of centers. So there are instantaneous center, two types. One is absolute instantaneous center. Absolute instantaneous center. Another is relative instantaneous center. Absolute instantaneous center and relative instantaneous center. What is absolute instantaneous center? If instantaneous center of one link, instantaneous center of one link is related, it's fixed with another link. Okay. So absolute instantaneous center will be instantaneous center of one link is fixed with respect to another link. One link is fixed with respect to another link. In that case, we can say that is absolute instantaneous center. Okay. So relative instantaneous center. So relative instantaneous center, that means there will be no fixed link. So one instantaneous center will be related to the another instantaneous center. In that case, we can say that is relative instantaneous center. Now, in a 4-bar mechanism, we have got I12, I13, I14, then I23, I24, then next was I34. Now among this 6 instantaneous center, I1 2 1 2 3 4, then I1 2 I2 3 I3 4 I1 4, that is I1 3, that is another is I2 4. Now you can see here that absolute instantaneous center, absolute IC, and number 2 is relative IC. So absolute instantaneous center, it will be number I12, number is I14, and another is I13. You can see absolute instantaneous center fixed with respect to another link. Okay, so that is absolute instantaneous center. And relative instantaneous center, so 3 links we have find out, that is I24, I23, and I34. Okay, so these are relative instantaneous center and these are absolute instantaneous center. Okay, so for finding out absolute velocity of one link, we should know the absolute instantaneous center of the particular link. We have to find out if you find out the relative velocity, we have to find out the relative instantaneous center. Okay, remember, to find out absolute velocity, we have to find out the absolute instantaneous center. If you want to find out the relative velocity, then you have to find out relative I center. Okay, now another method is there to find out this velocity, that is very important to know, that is angular velocity ratio method, or angular velocity ratio. Angular velocity ratio theorem. So angular velocity ratio theorem. Now in a 4-bar mechanism, so in that, by using this theorem, we can find out the angular velocity of one link if you know the instantaneous center and the absolute or relative velocity of another link. Okay, so you can see so there is 1 2 I13, I34, I14, so that is I13, that is I24, so 1 1 2 3 and 4. Now how to find out the angular velocity ratio? Angular velocity ratio theorem we have to find out. Now we can see that I24 instantaneous center I24, so it is between link number 2 and link number 4, and instantaneous center I13 is in between the link 1 and link 3. Now suppose this link is rotating with some angular velocity, suppose omega 2. Okay, and this link is rotating with some angular velocity, that is omega 4. Okay, now in that case you assume that we have to imagine that a disk, suppose a disk which is rotating with respect to this I center I12 and I center I14. Okay, suppose for that, suppose I24, which is rotating with respect to center I12 and with respect to center I14. So direction of velocity will be V24, so that will be perpendicular to this line. Now Vi24, which will be rotating with respect to this I center I12. So what will be the absolute what will be the velocity? V24. That V24, that will be angular velocity omega 2 into, with respect to this will be the length. So I12 I24. Okay. Now same disk which is rotating, suppose I24, we have to find out the absolute velocity V24 with respect to this point. With respect to this point, this is rotating with angular velocity of, that is, omega 4. So V24, that will be again V24, that will be omega 4 into I14 and I24. Okay, so these two are equal. So omega 2 I12 I24, that is equal to omega 4 I14 I24. Okay, so we can make one conclusion from here, that suppose that is for 24. Okay, so that is for 24. So if you find out, suppose 23, or if you can find out for 34, so we can write 34 23, so omega 2 I12 I23, that is equal to omega 3 I13 I23. So another conclusion we can make from 34, we can write omega 3 I13 I34, that is equal to omega 4 I14 I34, we can write. Okay, so angular velocity ratio theorem, from here you can see that omega 2 I12 I24, that is equal to omega 4 I14 I1 I24. So omega 2 by omega 4, that is equal to I12 I24 divided by I14 I24 divided by I12 I24. That means if you know the angular velocity of one link, By using this instantaneous center, we can find out the angular velocity of other links by using this theory. Okay, so I hope you have understood this angular velocity ratio theorem and how to find out the instantaneous center of a four-bar mechanism, or the position of link is different. Okay, so I think you have understood. Thank you.